started. Lecture 17. Today's in-class exercise is, I'm actually kind of excited about it because I think it's a really culminative experience. I think it's fair to say that this CAD exercise is really going to use just about every single one of the skills in AutoCAD that we've used to date. I also think it's fair to say that if you can do this, there's probably nothing on the upcoming exam next week that's really going to challenge you, okay? So I just want to give you a couple quick housekeeping items, and then I want to explain the assignment, okay? First off, if you have not yet scanned the attendance code, please do so. I'm going to upload the attendance grades by the end of the week. Now, everything through homework 7 and the first exam is graded. Homework 8 is being graded. And I'll just go ahead and tell you, my two TAs for the class are seniors, and they currently have some capstone presentations and deliverables that they have to do in order for them to graduate. So they're kind of busy. Between homework 8, homework 9, and the second exam, if I was a betting man, I would say let's just assume that all that's going to be graded by the time you come back from break. But it might take a little while. I mean, their capstone presentations are today, so they haven't had time to look at homework 8. Homework 9 is going to open today. It's going to close at 5 p.m. It's worth a little bit more. It's worth 60 points just because it's a little bit of a bigger assignment. Well, actually, it's not really bigger. It just encompasses a lot of different skills, okay? The only other thing that I want to mention before I start talking about this exercise is the exam. So we're going to review on Monday. We're going to celebrate on Wednesday, okay? So Wednesday, March 13th is our second exam. Everybody good with that? Yeah. Okay. Oh, one other thing, sorry. Inventor, okay? So when we come back from spring break, we're done with AutoCAD, and we're going to be using Inventor for the rest of the semester, okay? If you all installed AutoCAD, then installing Inventor is the exact same process. Only just instead of installing AutoCAD, you install Autodesk Inventor Pro. If you log into your Autodesk account, just install the program that looks like this. For you folks with Macs, unfortunately, Inventor is not Mac friendly, but you've got a couple of different ways of accessing it. You can access it through Cameo, or you could do like a parallels partition or something like that. But either way, you've got a couple options to do that. Sound good? Okay, so let me kind of explain the purpose of today's exercise, and then I'll hand everything out. Okay, so what we're going to be doing today is taking a look at an isometric view and then generating orthographic views. Okay, so let me kind of explain. Let's say that I were to give you the following part. Okay, so this is a three-dimensional rendering of a part. And what we want to do is take this three-dimensional rendering and convert it to two-dimensional representations. And we've talked about this before, and we've had some homework assignments related to this. Homework 4, we had a front, top, and side view of a 3D part. And homework 8, we had that second problem where I gave you a three-dimensional rendering, and you had to dimension the front, top, and side view. Okay? What we're going to do is we're going to represent a part like this in 2D. Now, one of the things, if you remember, there were 3 different ways of representing parts in 3D. There was isometric, there was oblique, and there was perspective. And one of the advantages of isometric is that the view can be scaled. You can actually use an engineering scale on an isometric view and actually measure the distances and whatnot. And we're going to do that today. Now, if I were to take this part, that was not what I wanted to do. I wanted to go here, okay? If I wanted to represent that part in 2D, it would probably look something like this. So this is what the front view looks like, this is what the top view looks like, and this is what the side view looks like. Now, it's kind of tough to see here on the screen, but one of the things that you might notice is that if you look at the front view, this front view over here, the top edge is solid, but right under the top edge, there's a little dashed line, a little hidden line that goes across that top edge. Does anybody kind of have an idea why that dashed line is there? It's the little groove on the top, right? It's like if you had X-ray vision and you looked through the front view, you would see that edge, right? So that's what that hidden line is for, okay? So to give you kind of maybe a more visceral idea of what that looks like, I have here a... let's look at this. I just made up a little part. Let's consider the following plate, okay? And when I say plate, what I mean is that this is a, three-dimensional part, right? So, it sort of looks something like this, okay? So here's the plate, and then the question is, what does the side view look like? So if I were to, look at this, like this, gotta love my artistic skills. There, that's the best you're gonna get out of me. If I were to look at the plate on the side, what would I see? Okay, well, if I were to look at it, I would see this, right? That's essentially what I would see. But are there any hidden features? Okay, well, first, so we've got a hole through the part, right? So probably what I would do is do something like this, right? And then maybe a dashed line like that and a dashed line like that. So the dashed lines represent the top and bottom edges of the hole, and then the red line represents the center of the hole. Okay? But are there any other features I'm missing? Right, there's a little notch up top. So probably what would happen is I would have a dashed line about like that, right? And so that's what the side view would look like, right? Make sense? I mean, the only solid features you would see are the actual, edges of the plate. But there are a lot of hidden features that you would want to represent. So I want you to keep this idea in mind while you prepare your drawings today, okay? So let me explain what you're going to do today, okay? So today, I'm going to give you this, okay? So I'm going to give you this. I made up this part, okay? And I'm going to give you this, and I want you to prepare front, top, and side views, okay? But one of the things that you're going to notice is that some of the dimensions I'm giving you, some of them I'm not, okay? And you'll notice that some of these are lettered, like dimension A, dimension B, etc. How are you going to determine those dimensions? With your scale, okay? So this drawing that you're going to be given is printed to scale, specifically 1 inch equals 20 millimeters. So this part is only about yay big, right, in the real world. But we're blowing it up a little bit so that we can see it on the drawing. So what you're going to do is take your scale and you're going to determine the unknown dimensions. And then what you are going to produce is this, okay? So I've given you generally what the side view looks like, but you've got to prepare a front view and a top view, okay? And not only that, but you're going to dimension it too. So instead of this saying like G, it's going to be, if G is 73, then it's going to be 73, whatever the dimension actually is. Does that make sense? Okay. I want to go through a couple things with you on this, just to make sure that everything's kind of clear. Let me pull up the PDF. Okay. So I'm giving you general directions on this, on how to set this up, but on this assignment, you are only uploading your final PDF. So as a result, you all have a lot more flexibility on how you want to actually do the AutoCAD work. Like, I'm not going to tell you how many layers to create, or how many, I'm not going to tell you how many layers to create, because I'm not going to get that at the end. All I'm going to get is a PDF. So you create as many layers as you think is necessary, okay? That's up to you, okay? But I have given you a couple of formatting guidelines that I'll think will help. So, for example, I want everybody to do an ANSI full bleed 17 by 11 at a 1 to 20 scale. So the rendering is at a 1 to 20 scale, but you're drawing it on an 11 by 17. So that'll give you enough room. Make sure the font is Roman S, okay? Now, if you followed along the class exercise on Monday, what I'll tell you is that from a drafting perspective, it will be a lot easier if you draft the title block, draft the scale block first. Draft those first, and then increase their scale, then draft the parts. Trust me. And make sure when you draft the title block that you also put a rectangle on the outside for the actual edges of the paper, so you can plot the window like we did on Monday. Okay? I've given you some information and some guidance on how to format your dimension style so that it shows up legibly. I've given you info on the plotting instructions. One thing that is going to pop up on this exercise is that when you draw hidden lines and dashed lines and center lines, they're probably not going to show up very visible on your final plot. And so what you're going to have to do is increase the scale of the line in order to make that doable. And I've given you instructions on how to do that. Okay? The point or the assignment's going to be worth 60 points. Again, a little bit more than the last assignments. And I would read this little notes and guidance on submission, because I guarantee you about 90% of the questions that you're going to have on this assignment will probably be answered here. Like, for example, I want the assignment to be, or the submission to be fully dimensioned. Okay? Well, what do I mean by fully dimensioned? Well, ensure that all the dimensions that are on the isometric view are on the final drawing, right? Because I gave you enough dimensions to fully draft the plot, so those dimensions should be on the orthographic views. If you forgot how to do the typical note, that shows you how to do that, and so on and so forth. Okay? Does that make sense? All right. So I'm going to turn it over to you and let you all get started, but I'll be here if you have any questions. So I'm going to pause the recording and start letting y'all get started.